Welcome to Unit 3, Equations, Lesson 5, Solving for a Variable or Isolating for a Variable. Today's learning goal, we're going to use inverse operations to solve for a variable in a linear relation where there are two more variables. Now, this is not completely true because it says linear there. That means every degree is 1. We're going to see an example later on where we have a degree of 2, which is fine. Alright, so if you could please turn to page 10 and 11 in your notes, and we'll get started. First of all, this is in your notes, but how do I isolate for variables? Just to review, we use inverse operation. What does that mean, Mr. Wills? That means if we have some addition to get rid of it, we use subtraction, or if we have subtraction, we use addition to get rid of it. Same thing with multiplication. If we have multiplication like 2x, we use division to get rid of it, so divided by 2. Or if we have division, we get rid of it by multiplying. So inverse operations are these two. Do the same thing on both sides of the equation. What does that mean, Mr. Wills? We're going to balance. And finally, you do add, subtract before you do multiply and divide. So this first, then this second. All right, let's get started. Here we go, and boom. Okay. So let's get started. Here we go. Here are my two questions. I've got 5x plus 10 is equal to 45. The other one is 5x plus 10y is equal to 45. Both solve for x. So we've seen familiar. This guy here is what I would call familiar. We've seen this many times, especially when we played Matho. And this is the unfamiliar. This is the new. So I want to take us to the familiar to the new today. All right, compare the questions. How are the questions similar? Now I wrote this down. If you don't have enough time to write it down, that's of course okay. You can pause the video. How are these two questions similar? Well, the first thing is they have the same coefficients. Right, 5, 10, and 45. Two terms on the left, and constant on the right. Anything else? No, that's it. How are they different? Well, first of all, the example on the left, or on the right, sorry, the new one has two variables, x and y, where this one doesn't. Also, the second term in the second example, so over here, has the variable y. Okay, so let's go to the familiar. Let's solve it. Here we go. I've got 5x plus 10 equals 45. I'll write that out again. 5x plus 10 equals 45. And of course, to get rid of this, I am going to subtract 10 from both sides. So subtract 10 from here, subtract 10 from here. That's so I can get that 5x by itself. So I'm going to have 5x is equal to 35. And then, of course, I divide both sides by the number in front. So it's 5 times x. The opposite of multiplying is dividing. So divide this side by 5. To balance it out, to divide this side by 5. What do I have? I have now x is equal to 7. Ooh. Let's do the same thing, but over here. So here, 5x plus 10y is equal to 45. This is a plus sign, by the way. All right, so first thing I want to do is I want to get this 5x by itself, so I want to get rid of this 10y, so I'm going to subtract both sides by not only 10, but the y, of course, as well. So subtract this by 10y as well. So again, balancing. Here we go, so I have 5x is equal to 45 minus 10y. So 10. Okay. Can I put these two things together? Over here I could. 45 minus 10, of course, is 35. 45 minus 10y. These are unlike terms, so I can't put them together. So what do I do now? Divide both sides by 5, divide by 5, and divide by 5. What do I have? I now have x is equal to 9 minus 45 divided by 5, of course, 9. 10y divided by 5, so I can divide the coefficients here. It's negative, because I got negative divided by positive. Negative 10 divided by 5 is negative 2. And of course, that y just hangs around. So there are my two answers. I can't do anything, I can't put these together, because I've got a constant and a variable, so those are stuck. So let's continue. What's similar about the way we solve these two? Well, first of all, we use opposite operations to isolate for x, right? I've got that x by itself on the left, and opposite operations, we subtracted, and then we divided, and we get our answer. What's different about how we solve them? Well, the solution of the first example is a constant, right? So when I get this, I got a constant on this side, a variable on this side, and then of course I divide to get this. Where the second one, I am still isolating for the x, but I have a variable on the other side, and that's okay. But my answer will now be a constant and a variable rather than just a constant. All right. What else? And that's really it. Okay, so really what we're doing today, the new stuff, is we're going to isolate for a variable and we are going to have a variable on the other side, and that's okay, but we're just going to leave it as is. So I'm going to walk through 5 examples with you, then you can start the homework. Here we go. Let's go to the first question. Here, the first question is 3x minus y equals x. So what I want to do here is I want to isolate for this 3x. I want to get this guy by itself. So what do I need to do on this side? I need to get rid of this y. So I've got a plus y, opposite of adding is subtracting, so I'm going to subtract y. But what I do to one side to the other, so I'm going to subtract y on this side as well. What do I have then, Mr. Wills? Well, I have 3x is equal to 5 minus y. Yeah, there it is. Okay, now I've got 3 times x, so of course I'm going to divide this side by 3, so divide this side by 3, and I'm also going to divide this, every term here, by 3. So what do I have now? I've got this. X is equal to 5 over 3. I can't simplify, that's what it is. 5 over 3 minus y over 3. You could also write it like this, or 5 minus y all over 3. Either one is acceptable. They really mean the same thing, but I always like to simplify each term if I can. Here I can't, and there's my final answer. Alright, let's go for the next one. Here's the next one. I want to isolate for y. So I want to isolate for this guy. Notice how I'm including the sign here. So what do I want rid of first? I want rid of this 2x. How to get rid of it? It's really like a plus 2x, so I want to subtract 2x. I subtract 2x from this side, subtract 2x from this side. Okay, then what do I have, Mr. Wills? Well, I've got this. 5y equals negative 10 minus 2x. What do I do now? I divide every term by 5. So what do I have now? I've got, on this side I've got my y by itself, woohoo. On this side, negative 10 divided by 5 is negative 2. Over here I've got negative 2 divided by 5 is, well, is just negative 2 over 5, not changing that to a decimal, and then it's negative 2 over 5, and then the x is still hanging around, so there we go. And that, folks, is my final answer. So I circled the one I want to isolate for. You don't have to circle it, but I like to show that I'm isolating for this. Got rid of the other term on that side, and then I divided. All right, let's go to the next one. Ooh, fractions. Now, again, same thing here. I want to isolate for c, but before I isolate for c, I'm going to destroy the fraction. How do I destroy the fraction? I'm going to multiply by the LCD. My LCD, since I only have one denominator, is 5. So this is like yesterday's lesson. So I got an LCD of 5 because it's the only denominator I have. So what I'm going to do here is multiply every term by 5. So 5f is equal to 5 bracket 9 over 5c plus 5 times 32. Alright, so here I get 5f is equal to, I'm going to pull this guy out. Here he is here. So I'm going to have 5 over 5, which of course is just 1, times 9c plus, watch this, 5 times 32 is 160. I don't know what's 160 because I know 10 times 32 is 320. Divide that by half, or divide that by 2, sorry, I get 160. Alright, anyways. So I have 5f is equal to, 5 divided by 5 is 1, so I'm just left with 1 times 9c is 9c. Plus 160. Alright, here we go. Now I want to isolate for my c. I want to isolate for this guy here. So what do I want to do first? Let's take away 160 from both sides first. Take away 160, take away 160. Once I get rid of the fraction. So what do I have? I'm going to have 5f minus 160 is equal to 9c. Now, of course, I'm going to divide every term by 9. So divide this by 9, divide this by 9, and divide this by 9. What do I have? Well, can't simplify 9 over 5, or 5 over 9, sorry, so I have 5 over 9. C minus 160 divided by 9. Doesn't work out, so I still have the 160 divided by 9. And this is equal to C. So there it is. So C is equal to all of this. Okay, so that's it. That's it. All right, here's the last one, or the second last one, I should say. I want to isolate for S. So I want to isolate for this. What do I do first? Well, I want the S by itself, so I'm going to take away B from both sides. So take away B from this side. All right, so here I'm going to have P minus B is equal to 2S And then of course I divide everything by 2. Divide this by 2, divide this by 2, and divide this by 2. And so I get here P over 2 minus B over 2 is equal to S. And I'm done. There it is. All right. Last question. Here we go. I promised a 10-minute video. I'm not going to quite deliver on this, but let's do the last one. Here's the last one. So I have this. I want to isolate for, oh shoot. Do I have what I'm going to isolate for? So let's say I'm going to isolate for R here. I didn't write that down, but I want to isolate slash solve for R. All right. So I'm going to rewrite this out again. So I have A, oops, oh great. I'm going to talk through this while I get my pen working again. Which of course it's not. So I have A is equal to pi r squared. I want to isolate for the r squared, so guess what? I want to get rid of this pi. How do I get rid of this pi? Well, I'm going to divide this side by pi. I divide this by pi, I have to also divide this side by pi. So what do I have then? I have A over pi is equal to r squared. So this isn't linear because I've got to square it here. Now, what's the opposite of squaring something? The opposite of squaring something is square rooting it. So I'm going to square root this side. That'll get rid of the r squared. That'll just leave r. But what I do to one side to the other side, so I can also divide this side by r. So what am I left with? I'm left with, as a final answer, r is equal to the square root of a over pi. And there's my final answer. A few notes about this one. Note number 1. Notice how I've got the r on the left or on the right, and then I have it on the left. You can always flip-flop them like that. That's okay. As long as you take whatever's on the right and move it to the left, and whatever's on the left move it to the right, that's fine. You can do that. It's still balanced. It's just like you're moving it over on the other sides of the scale. The other note is the opposite of squaring something is always square rooting it, so that's why I square rooted over here. I square rooted both sides. So I square rooted this, and I square rooted this. Oh, don't move that. Yes. Okay. And that's that. So there's my answer. All right, final thing, key ideas. You can use balancing to isolate any variable in the equation. This is the effect of solving for that variable in terms of other variables in the equation, but I will always tell you which variable to isolate for. All right, finally to finish it off, the fun work. Woohoo, Mr. Wills. Yeah, I know you're excited. So here it is, fun work. Work through that. Please check your answers. They're in the back of the book. And that's where I'll leave you. If there's any questions, you can come talk to me the next tomorrow, where I'll give you probably a warm-up question like this, and then we'll move into the next lesson, which is word problems. Thank you for listening.